Hello friends, in this video we are going to discuss about deterministic signals and non-deterministic signals. It is the one of the important classification of systems and signals. First, let's see what is the definition for deterministic signal. A signal is said to be deterministic if there is no uncertainty over a signal at any instant of time. If a signal is said to be deterministic, there is no uncertainty present in the signal. At any point, we have a certain value, there is no uncertainty, then the type of signals are known as deterministic signals. That is, its instantaneous value can be predicted. Its instantaneous values can be predicted. That means a deterministic signal is a signal, it is having certain values at any point. It does not have any uncertainty, and at any point we can predict the value of the signal. And also it can be represented by the mathematical equation. If the system is having the not a system, if the signal is having the mathematical equation, then that type of signals is known as deterministic signal. Blindly we can follow this rule. Okay, if the system is having not a system, if the signal is having mathematical equation, then the types of signals are known as deterministic signal. Here observe the examples. Here y of t is equal to bt. Y of t is a signal, b into t, it's a mathematical representation of that y of t signal. And x of t is equal to a into sin t. Here x of t is a signal and a sin t is the mathematical representation. And here also x of n is equal to 2 when n greater than or equal to 0, 0 otherwise. It is also one of the type of signal. Okay, now let's see examples for deterministic signal. Here observe, it is a sinusoidal signal. It is a sinusoidal signal with discrete time. Here time is discrete, and we can determine this. We can write mathematical equation for sinusoidal signal. For example, x of n equal to a cos omega nt. It is the mathematical representation for this signal. So we can write the mathematical equation for this signal. So it's called as what signal? Deterministic signal. Okay, here observe next thing. Here this is also, it is the ramp signal. It is ramp signal. Here also it is the ramp signal. We can write mathematical equation for ramp signal also. That is, ramp signal is denoted by r of t equal to a t at. It is the mathematical representation for ramp signal. Okay, now let's see what is non-deterministic signal. Okay, here observe what is non-deterministic signal means. Here observe non-deterministic signal. What is the definition for non-deterministic signal? Here let's see. A signal is said to be random if there is uncertainty over a signal. A signal is said to be random if there is uncertainty over a signal at any instant of time. That is, its instantaneous value cannot be predicted. Here observe, in case of deterministic signal, the signal is having uncertainty. Okay, the signal is not having uncertainty in case of deterministic signal, but in case of non-deterministic signal, the signal is having uncertainty. That is, we can't predict the exact value of the signal at the particular time. Okay, and its instantaneous values cannot be predicted. Here observe, it can't be represented by mathematical equation. In case of deterministic signal, we can represent deterministic signal by using mathematical equation, but in case of non-deterministic signals, we can't represent it in mathematical equation. Observe here, it is a random signal. It is a random signal. See here, this signal is a random signal. We can't represent this signal as a mathematical representation. We can represent for a sine wave as well as ramp wave as well as triangular wave, but in this type of signals we can't represent in mathematical way. Okay, so this type of signals is known as non-deterministic signal. Non-deterministic signals is also known as random signals. Okay, here observe, it is also called as random signals. Example for non-deterministic signal is thermal noise signal generated in electric circuit and EEG signals. EEG signals are also non-deterministic signals and thermal noise also non-deterministic signals. Okay, this is about deterministic and non-deterministic signals. I hope you understood. Thank you. Thank you for watching this video.